Hi everybody, thanks for joining us here today. I'm Mark Bay. I'm one of the market segment managers with Makino. We are at Makino's Center of Excellence in Auburn Hills, Michigan, and I'm here with Robert.
Yeah, my name is Robert Edinburgh. I'm an application engineer for EDM here in Auburn Hills.
And Robert, today we wanted to look at best practices of programming applying keyway into a gear. So trying to take, your recommendations and your tips. Now, I know oftentimes you see in shops that by default they'll just burn straight down for a blind keyhole, which obviously is going to get you to the result. Is that what you're going to do here as well, or are you taking a different approach?
What we would prefer to do is to burn from the X or Y axis on the side, because we can cover more ground with the surface area of the electrode. So by burning, for instance, we're going to be burning a 375 key slot. We don't want to burn it from the top because it's only going to be 375 square area from the top. So if we can burn that from the side an inch down, then we're talking, I believe it's like 875 or somewhere around there square area. And we can put more power to it to allow it to go a lot faster.
So that's like covering 2.5 times surface.
We're looking at close to 3. A little more than 2.5 times the surface, but we're looking at almost three times much gram removal rate too.
Okay, that's the key. So
definitely the key.
So that means like 3 times as fast, right?
Yeah, basically.
Essentially.
So if you want, I can show you how we can quickly program that on the machine and kind of give you a little demonstration of how easy it is to program.
That would be great, Robert. Thank you.
All right, perfect.
Let's take it over.
So after we've opened up a new program in our project, we pick the technology that we're going to be burning. Open side, solid, or anything like that, tap, rib. We're going to be burning this on an open side. The next thing you want to do is pick out what material, which is steel, and then what kind of electrode bit we're going to be using, which is graphite. Okay. Then the next thing you want to do is you want to pick out the spark area. The spark area is very important because that's going to depend on how much power we can actually put to the electrode to allow it to remove the material. So too small of a spark area, you're not going to put enough power to it. It's going to take forever to burn, right? Too much, and it's going to wind up shorting out, having issues, and it's going to take all day and not be right and overburn your part possibly. So what we want to do is make sure we pick the right one, which we can do that by width times length to square root, which would give us, I believe, a little over 800 on this one. So that 800 will fall into your drop box range of 0.6 to 1.2. And that's going to give us a good range when it picks the technology for us.
And that's where we get like the about 3 times faster advantage of doing the side burn versus from top down.
That is correct. The next thing, it just wants to know what is the range that we're going to be dropping down for the depth on it. And we're going to be going an inch, so we'll pick up to an inch. That's fine. And then the next thing it wants to know is what kind of surface finish. And we got that from the drawing, and I believe it's a VDI of 22 is what we're looking for. So we see a VDI of 17, VDI of 19 to 24. Well, I want to be better in the 24, so we're going to pick 19, which will take us out to a process of 14 on it. So we picked that one. All right. The next thing we want to do is we just scroll down the page, going from left to right, is we want to tell it what kind of orbit we're going to be doing, what orbit on it. We're going to pick a square orbit for it. The next thing wants to know is the reduction. So,
but what made you decide to use that specific reduction on the electrode size?
Well, generally you're going to look at your print. You're going to look for that max corner radius, and if that max corner radius is say 10, then we can drop down to an 8, giving us enough. If we needed to actually burn away, we would still have enough in that material to achieve that max corner radius of 10. Anyway, so if you had a max corner radius of say 6, then your reduction would be a 4, to say. That's an easy way to do it.
Yep.
Also, if your max corner radius is really large, it's 15, 40, it doesn't really matter. The bigger you can make that reduction, the faster we can make this burn and more material we can get out, right? So we want to try to achieve the most reduction that we can, if we can.
Okay, thank you.
Okay. So another thing that we do, this check box right here, this tells it that I don't want to orbit the whole time I'm burning into it and roughing all that material. I just want to kind of plunge in as fast as I can into the side. So once it gets it to the depth that I've told it to get to, then it will then start orbiting out or whatever. Generally, that's going to burn a little faster. So by checking that box, it's going to allow us to activate that. The next thing, you go to your options set. If there's any other options, such as the technology is Super Spark, if we had tapers or anything, which we don't on this one, or if we were running ribs or anything. So on here, we're just going to click the tank height, so the tank will automatically come up in the program and go down after the machining starts. Then when we're all done, it's going to tell us what the actual technology is going to recommend that we burn into it. We'll hit OK, and it's going to move over to the positioning side of things. Okay. And now remember, we're going to be burning from the side, so we want to go ahead and tell it we're going to be burning off of the edge when we start it, and then we're going to be burning, take our Z down to the depth that we want to start at.
Robert, let me ask you a question. So you're setting the Z to 1, but your reduction was in 8,000ths.
Yes.
So how do you make sure that you don't go too deep then?
So we have a function. So what you could do is you can manually make your reduction 8,000 be 900 92 if you wanted to. But we have a function in our machine that's called rise position Z by reduction in the side machining. So anytime we are burning in the side and we already put it to our depth, the machine will already know if this button is turned on to raise it up, whatever your reduction is. So in this case, 8,000. That way, when it orbits around and down, it will not burn too deep.
Okay, so this way you're guaranteed to hit your depth and not go over it.
Yes, that's exactly what it is. After we've put our position in, now we need to tell it what we're going to be burning. And we can tell it by multi-axis, which allows us to burn in any direction, up, down, sideways, whatever. In this case, we're going to be burning in the X direction. So we've set it to burn in, and we're going to be burning this in 375 into it. The next step is we got to tell it what electrode we're going to be using today. We're only going to be using one electrode, so we're going to call that a finish electrode, and it's already put in a reduction of 8 into it. So as soon as we're done with that, we got our tool in, we hit save, it tells us it's processing, we hit save again, we'll give it a name. We gave it a name. It is now stored over here. I can transfer it out to go look at it, and we can come look at it, and we'll open it up. And there's our program that the machine just created for us to be able to burn this blind key into a gear.
Robert, thank you again for taking us through the process of programming the blind keyway.
Not a problem. It's my pleasure.
And also, great explanation why it's beneficial to do the side burn in this case. Well, thank you. And thanks to all our listeners and viewers here for joining us today. We are going to open this up to a live Q&A now.
Good afternoon, everybody. Thanks for attending. I also wanted to point out that within the chat and Q&A functions that you see circled in the slide, you can post some questions to us. I am here with Brian Coward, EDM Product Line Manager, and also Dave Robinson, EDM Sales Specialist. Thank you, gentlemen, for joining. So let me see at questions and Q&A. So here's the first one is, so let me check. Other than the internal corner radius, what other factors play into determining electrode reduction?
I'll take that one, Mark. So the biggest thing is the area of the burn. So that's really our first determining factor, again, is the corner radius. So that's the limiting factor. Whatever it is, your reduction has to be that or smaller than that. Second factor definitely is the area. So in our data charts, or what we call model data charts, we have overburns or the reduction in that section for each area. So let's say we had that 875 keyway for area. There's a reduction that goes with that. If we were to reduce it any more than that, we couldn't take advantage of the spark because it's not large enough in that area to take advantage of that large reduction. So matching the reduction to the area makes the machine that efficient. So the 8 thou reduction that was calculated in the webinar is the correct reduction for that 875 area. So that's key to be most efficient with the machine. But again, limiting factor is that corner radius. So we can't take a 10 thou corner radius and orbit it 12 thou and get that radius. So that is that limitation.
Okay, great. Thank you. I got one more here. And in our shop, we always burn in Z-axis. What is the advantage of burning in the XY axis?
Yeah, actually, good question. So most EDM machines, Z-axis burning is standard. It definitely is the fastest jump axis. But in this case, when we can burn sideways with large area, so that 875 area versus 375 on the small square from the top, we can't put enough power through that 375 area to make it efficient. So going in from the side, yes, we reduce the jump speed, but we increase the power 3 or 4 times, and that's what makes that side burn more efficient. So a very simple process. So anytime we can increase the surface area, that's what's going to make the machine more efficient versus the jump speed. So definitely going with the reduction and the side burn is the way to go.
Okay, great.
Great.
Next question I got is this type of conversational programming applicable when using a fourth axis? Could you use this to program helical burning?
So we can do helical burning through the control. So what we refer to as a ZC burn. So the Z would move up and down vertically, and then our what we call C axis, that's the rotational. So we can rotate the C axis and move the Z up and down at the same time to do synchronized helical burning. So if you had a helical gear or helical threads, something like that, it gets synced. So its jump motion would be the same reverse as the burning ZC direction as well. So very simple in the program. So we're just going to give it X amount of C rotations for X amount of Z burning depth. So, and the machine controls the jump, the retract jump, or if you had to retract out of the cut for any reason. So the machine controls all of that movement. So it is a very, very simple process. It even calculates. So when we have a start point above the workpiece, it also will calculate that distance and add in the needed additional ZC movement in a helical burn as well.
Hey, so Dave, I got a question about that. So,
yep.
So that programming technique is available in the project programming. So the similar thing that was just shown to us by Robert. So we're just entering in those items and then it'll.
Yep, exactly. And even in some of the helical gear machining, we take it to a pretty high level on the gear side. So guys that do this day in and day out with lead entry or module entry type scenarios, that this is their daily work. All of that is in the control under this helical burning situation. So yeah, very high level programming that used to be very difficult. Now it's just basically a conversational answering questions about the burn, and the program is created from that. So we've made it very, very simplistic that way.
Okay, great.
Good. Thank you. I got one more question here. And how does the machine know to orbit correctly when burning sideways?
Oh, okay. Yep. Yeah. Good question. So like Robert Edinburgh had showed you, so when it does the orbit, so if we were at 1 inch with the orbit, we would have been at 1 inch 8 thou. So that the side reduction by machining lifts that up that 8 thou. But then, so our creation of our orbit pattern is just basically a point-to-point movement. So it goes from our start point, and then our depth is that the movement to how far we're going to burn. So I think it was 375 deep in the example. So then it's just point-to-point movement in the x-axis, and it orbits around those 2 points. So in this case, it was a square orbit, so we're going to get sharp corners. If it was round, then it would just be point-to-point movement with radius corners. So it takes a lot of the calculation work out, that it's all point-to-point movement. So if we had to do it on a vector, same thing. It creates that vector from start point to end point, and then orbits around the basically that line that those points create, and orbits around that vector. So very simple, nothing that the operator even has to take into consideration. The machine does all that, and all of those orbit patterns that we select are icon or visual based programming as far as those orbit patterns. So makes it simple.
Okay, great. Thank you. I think for now, we don't have any further questions. So I wanted to thank everybody for attending. Dave and Brian, thank you as well. And I welcome everybody to also check out the Makino YouTube channel, where this broadcast is going to be posted alongside many other how-tos and short tech tip videos. So thank you again, and have a good afternoon, everybody.